All right, so we're back. We're going to talk about covalent bonds. All right, so covalent bonds are, I like to call them the nice bonds. These are between two non-metals. Non-metals are located on what side of the periodic table? Right, the right side. Good job. All right, so how do we remember that this is the nice bond? Well, covalent, right? Cooperative means to work together. Okay, coworker. I like to think Miss Red, Miss Sorensen, right? They're the nice bonds. We work together, we share, we think of ideas and we share them. How do we make science really fun for you guys? So covalent, coworker, nice, cooperative. So let's rewind for a minute and let's talk about in your body we have many covalent compounds. Covalent compounds are basically when atoms will share electrons. I can't emphasize this enough. This is sharing, 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 carrying, sharing, covalent, sharing, covalent. The bond forms when atoms share electrons, which is our covalent bond. Share, share, share. Nice bonds, covalent. Okay. So atoms share electrons in their to fill their outermost energy level. Remember, we want them all to be at what number? 8. We want all of these bonds to have a full ring. So we are going to write that covalent happens between two nonmetals. And what this is going to basically create is a molecule. Groups of atoms make up a covalent compound, which is called a molecule. We've talked about this before, but as a reminder, a molecule is the smallest particle that you can divide a compound into and still have that compound. So everybody knows H2O, right? If you break down water down further, it's not going to be water anymore. What would it be? Well, it's going to have hydrogen and oxygen. Okay. And that's where we're talking about molecules. So, how this forms is through sharing. Okay. Share, share, share. Now, in order to visualize how this looks, we do need to talk about the electron dot or Lewis dot diagram. I absolutely love teaching this because I find that it's pretty simple. An electron dot diagram is basically just a model or a way for you to see the valence electrons in an atom. So let's say that it is in group 1, the element group 1. Let's talk hydrogen. Well, hydrogen's in group 1, so how many dots would it have? 1. Very good. You guys got this. It's really that easy. So electron dot diagrams can help you predict how atoms might bond. So to draw an electron dot diagram, we're going to write this symbol and then you're going to place 1 dot around the symbol for every valence electron shown. So let's start with a great example of carbon. Carbon is in what group? 14, right? So that means it's going to have 4 valence electrons. So it's going to have 1 on the top, 1 on the right, 1 underneath it, and 1 to the left. So you basically just draw the letter C and you're going to put a dot on top, to the right, to the underneath, and then to the left. So 4, which means if we want it to be stable at what number? What's the magic number? 8. Okay. And this has 4. How many more would it need to become a full outermost energy level? It's going to need 4 more because 4 plus 4 is 8. You've got this. All right, let's talk about oxygen. Here's oxygen. Oxygen is in what group? Look at that periodic table. 16. Awesome. So if it's 16, that means it's going to have 1 dot, 2 dot, 3 dot, 4 dot. So it's going to go up, to the right, down, left. And then it's going to have 2 more. It's going to have 1 on top and 1 to the left. So in total, this is going to have how many? 6, right? And we need to get to what number? 8. Okay, so if we have 6, what number plus 6 equals 8? Exactly, 2. So it's going to bond with somebody that has 2 electrons to fill their outermost energy rings. All right, we've done carbon, we've done oxygen, but what about krypton? Find krypton on your periodic table. All right, it's in group 18, which means it has 8 valence electrons. Does krypton have to bond with anybody? It's already full. Oh, I forgot. Right. Krypton is non-reactive because it's in group 18, a noble gas. It does not bond with anyone else. It does not need no more electrons. I don't need any electrons. I'm full. I'm good. All right. So that's kind of what Lewis dot or electron dot diagrams are. You might hear those words different ways, but it's the same thing. So now we're going to show you how this actually bonds, okay? So remember, hydrogen is in group 1, all right? So because it's in group 1, it's going to have 1 electron. So these two are going to combine, and they're going to have a full ring now, okay? They have 2. Hydrogen is remember, you can have a full ring at 2 or 8. In this case, they might bond with oxygen because oxygen has 6, but you can have a diatomic molecule just like this. Di means 2, diatomic. So just to make sure, we'll talk about that more in a minute. But fluorine, right? So if you look at fluorine, fluorine is in group 17, which is our halogens. And you can have 2 of these come together, and they're just going to share 1 of their electrons. And that means that now they've got a full set. You can see right here that the green one's going to have 2, 4, 6, and now 8. And the orange one has 2, 4, 6, 8. So they're all full. And that's called the diatomic. Diatomic means 2. So F2 or H2. Okay. So here is a great example of hydrogen, right? They come together and then you put a little line in between it to know that they are sharing, kind of like this. That's kind of when we built our molecules one day, that's kind of that visual understanding. And then here you've got your fluorine coming together, and now you've got it. Now, this doesn't always mean that it has to only be like H2 or F2. It could be like CO, carbon, and oxygen. So there's other elements that can combine. I just wanted to kind of give you guys a visual of what a diatomic molecule is. And we'll practice this a little bit more. So here's another example of a covalent bond over here. You have your hydrogen, which has 1. You have a hydrogen that has 1. And now all of a sudden you have oxygen, which has 6, right? 1, 2, 3, 4, 5, 6. So now these guys are sharing, and they have oxygen is stable because it has 8. And these guys are also stable. So I'm going to let you guys kind of look at this video and listen to Moo Math teaching you ionic and covalent bonding. I'm going to pause and have you guys make sure you have your notes down. So I'm going to kind of go back if you need this. Make sure you have this down for covalent.